Okay, let's give you guys some more practice. So another piecewise function here. Find the limit of f of x as x approaches positive 2. It must obey this when x is strictly less than 2, and it will obey this when x is greater or equal to 2. Okay, or sketch this function, and then you can see the answer to this as x approaches positive 2. So press pause and have a go. Okay, so to do this here, well, when x is strictly less than 2, it will obey this. So here you've got your quadratic here. So 0 squared is 0, 1 squared is 1, negative 1 squared is 1, negative 2 squared is 4, and this here would be 9, so we're up here, and then positive 1 squared would be 1, 2 squared would be 4. But don't forget, this is strictly less than 2, so your diagram would look like this. Okay, so you've got your quadratic looking like this. Okay, and then it will obey this when x is greater or equal to 2. So this here is like your straight line, y equals. This is your straight line here, where the intercept is is positive 5, and it has a gradient of negative 1. So in a way, it's a straight line going down like this. Oops, it should be a straight line going down like this. Hang on. It should be a straight line going down something like this. Something like this. Yeah, something like this. But the thing is, it's only valid for x being greater or equal to 2. So it's only valid from the right hand side of this here. So you see, your diagram should look like this. I should erase this here. Okay. Yeah. So your diagram will look something like this. Okay. So because you've got a black circle here, because this is x is greater or equal to 2. So this one here is strictly less. X is strictly less than 2. That's why you've got a white circle here. Now, once you've drawn your diagram, then you can see, well, you can answer this question here. As x approaches 2, so x approaching 2, that means from the left-hand side here, as you approach 2 here, you actually head towards 4. Okay, so here you head towards 4, and then from the right-hand side here, you head towards 3. You head towards 3. You see, in order for a limit to exist, you have to head towards the same point from the left-hand side and from the right-hand side here. Well, here we've got a case where from the left-hand side here, we are approaching 4, and then from the right-hand side here, we are approaching 3. So here the limit does not exist, because in order for a limit to exist, they have to head towards the same limit. Here, from the left-hand side, you're heading towards 4, and then from the right-hand side, you're heading towards 3. So here, well, the limit here does not exist. Okay, so if you look at your diagram again, it should look something like this. Okay, well, from the left-hand side here, you're approaching positive 4, and then from the left-hand side here, you're approaching 3. So here the limit does not exist. Okay, so that's your answer. Limit does not exist. Okay.